talk about radicals. Basically, those are squares and square roots. I'll explain here in a second what that is and what that looks like. Determine whether a given root is rational, irrational, or not a real number. I'll show you how to use a calculator / Desmos to figure that out. Find a cube and fourth and other roots. And then the last thing I'm going to do is I just want to show you graphs. We're not going to actually graph these things. Graphing is super important. I see the reason why. I understand why. To be honest, we're just not going to deal with that right now. So, anyways, changing my gain on my mic a little bit. Just kidding, that did nothing. Well, that's good to know. Okay, anyways, so maybe I can gain it down here. Sorry if it's coming in a little hot today. Check gain 1, 2. Okay, perfect. So we're talking about square roots. So when you look at a square root, normally they have a radical symbol. Sorry, give me 1 second here. Gotta love this no editing thing. But normally have a radical symbol. Most of the time there is a small 2 in here that a lot of you don't see. So there's the radical symbol. The radical is the total thing. So it's both the radical symbol and the radicand, which is the thing underneath. So anyways, hopefully that made sense. So the radical symbol is the blue one. Radicand is anything underneath, and then the radical is the whole thing. So as we go through this lesson, hopefully I will be utilizing those words in the correct order, or just the correct description. Okay, so finding square roots, we're looking at right here. So the square root of 1 is equal to 1, since 1 squared is 1. Hopefully that makes sense. So it makes a little bit more sense down here. And I utilize this a lot, like when I ask people what the square root of 4 is, a lot of people are like, I don't know what the square root of 4 is. But if you ask yourself what number multiplied by itself will give you 4, hopefully you'd be able to say 2 times 2 is 4. So these are all of our perfect squares over here, 1, 4, 9, 16, 25, 36, 49. And then when we're talking about square roots, the square root of 64 is going to be 8, because 8 times 8 is 64. So hopefully that chart helps a little bit. I just wanted, that wasn't originally in here, but I wanted to throw it in there because I think it's super helpful. All right, so find all the square roots of 64. So this is where it gets a little interesting, because I see the word all there. So originally, you might say to yourself, hey, I don't know, like, what do you mean all? There's only 1, right? Matt, you just told me the square root of 64 is 8, because 8 times 8 is 64. So I completely agree. 8 times 8 is 64. But there's one other one. What? That doesn't make sense. Well, hopefully you guys remember what a negative times a negative is. So actually negative 8 times negative 8 is also positive 64. So my square roots are actually 8 and negative 8. So hopefully it made a little bit more sense. When we're talking about squares, the biggest thing here is remembering when we take a square times a square, we get, where negative times a negative, we get a positive. So that's what this kind of chart says. So, and this is one thing that I don't like at all, but your book does it. So I just want to walk you through it a little bit. So the square root of a is the positive or principal square root of a. So when we're talking about the square root of 64, they're calling the positive / principal square root 8, where they're calling that negative 8 is written like this. So it throws me off a little bit. So anyways, hopefully I don't want to explain anymore because it's super confusing, but as I go forward, I will kind of hint on that, and hopefully that makes sense. So go ahead and take a minute, see if you can find these out, and then I'll be right back. Okay, so hopefully, I mean, you can use a calculator, you can use Desmos on this. So the square root of that is going to be 13, positive and negative, I guess. No, in this case it's not. No, I lied. That's just going to be positive. This one, the square root of 225 is going to be 15, but because of this negative out front, it's going to be a negative 15. So hopefully that made sense. This one, you can actually separate them. So that's the thing I love about square roots. You can separate them, and then you can say, well, what's the square root of 25? That's 5. What's the square root of 64? That's 8. So this is just positive 8. And then I believe this one is 0.07. I could be wrong there, though. No, 0.7? I don't know, 0.7 times 0.7. Yeah, I think that's just supposed to be 0.7. So anyways, hopefully that was good. The biggest one is probably this C one right here. Just knowing you can separate them, which as we get further along the lesson, that also means that you can bring them back together. Okay, so then if I asked you to do these ones, It says find the square of each radical expression. Okay, so what they want is they want you to square this. Okay, so what happens when you square this? Well, basically, the square root and the square what's called inverses. So when you square a radical, basically, it just gets rid of the radical sign. Wait, radical sign, sure. So that's just 17. This one then, I think they want you to do that. So I think that's going to be a positive 31. I don't know. Sure, we'll go with that. And then this one is just going to get rid of 2x squared plus 3. Sorry about the confusion on B. So it's one of those things that Pearson has in their mind how they want to do square roots, and I have in my mind how I do square roots. So for me, like, I would say that this is negative 31, but I think they're going to group this whole thing. And the reason why I say that is because if you take the square root, like, I read this as negative 1 times the square root of 31. So if you're squaring this, then you get negative 1 times 31, which is negative 31. But, I don't know, for some reason they don't look at it that way. So anyways, now we're going to talk about rational, irrational, or not irrational. So hopefully that makes sense. So when you're called to square a square root, you're just going to basically take off the radical sign. So here's some perfect squares. So we have rational, irrational, or not a real number. Okay, so here's the deal. I don't know what the next slide says. Okay, so this one, for some reason they showed you all rational roots. And so what it means to be a rational root is if you take the square root of this number over here, you get what I call a pretty number. So you get something that is going to be 5, or you get something that's going to be 10, or you get something that's going to be 2/3. Now, I don't know if you guys remember the difference between rational and irrational, but the little thing that I had, that a rational number, those repeat, and those terminate. Where an irrational number, and the famous one of that is pi. So it's no repeats and no terminates. Okay, so what I mean by that is if we go to the next slide, the square root of 27. So I'm going to log out of here real quick and get, well, yeah, sorry, I just told you it was irrational, but we're going to go to our friend Desmos. To use Desmos with some of the square roots, you're going to click on this little keyboard here. You're going to click on there, and you're going to hit 27 and see this number right here. So this number is going to keep going on forever. Although it only shows you like 11 or 12 digits, it's going to keep going on forever. And if you try to find a repeat value in there, hopefully you can't see that. Hopefully you guys see that there's no values that are repeating in there. So if we go back to our numbers here, hopefully you guys can see this. Yeah, if you go back to our numbers there, let's try the square root of 36. So if I come in here and I go to the square root of 36, it's just 6. So that one, technically, is going to be rational. And then if I take a square root of any negative number, then that's going to be not a real number. That's what they're talking about. Okay. So hopefully that made sense. So the biggest thing with that is sticking in Desmos. If they're perfect squares, they're going to be fine. They're going to be rationals. But if they're non-perfect squares, they're going to be irrationals. And if they're negative numbers, they're going to be not a real number. Hopefully that makes sense. All right, so let's look at this guy. So I kind of hinted at this earlier, but when we're talking about square root signs, the normal square root sign normally has an index of 2, but you can have things like cube roots. So remember, just as a review, the square root of 64, we asked ourselves, there is some number, times some number that equals 64. And so that number in that case would be 8. Here, because of the 3, we're saying that there's some number times some number times some number that's going to equal 64. In this case, that number equals 4. Because 4 times 4 is 16 times 4 is 64. So when we're talking about cube roots, the cube root of 64 is 4. So similar here. Now this is crazy because you're like, man, I thought you said negative numbers don't work. Well, think about it. Is there some number times some number times some number that equals negative 27? I would hint to say that that number is negative 3, because negative 3 times negative 3 is 9, times negative 3 is negative 27. Crazy, right? Again, you can stick these into Desmos. Here, let me show you how to stick this one into Desmos. So we're looking for 512. Sorry. So again, down here, oh gosh, where is it? A function? Let's see, I haven't really dealt with this yet. Oh, right there. So you have to go to functions, up to miscellaneous, and then that one. So this is going to be the cube root of 512, and that's going to be 8. Sorry. And then the last one, you can separate them just like you could square roots. So this one is actually going to be, make sure I've got time. I've got a little bit of time. This one is actually going to be the cube root of 125 over the cube root of 216, which I believe is 5 over 6. Same thing with this one. We're talking about fourth roots. This one is not a real number. Fifth roots you can even do. Fifth roots. So the hint is, if you have a negative number under here, as long as your index is odd, then you're fine. If it's even, that's when you get into trouble. And then let's just look at what a square root function looks like. And here's why you can't have negative square roots. Because if we look at the graph, you'll notice that there's nothing down here, right? And there's nothing over here. So this is just the normal graph of the square root of x squared. So there's nothing, you can't have any negative numbers because it doesn't show up in the graph. And this just means that square roots can never be negative either, except if we have a negative out front, which then flips the graph to look something like that. So here on the normal square root of x domain, we're talking about the x value. There's no questions on this on your homework, and range is the y value. Similarly, why does it work with negatives? When we're looking at cubes here, look what happens now. Now, we can stick negative x's in there because of this graph right here. So here, in a cube root, our x values can be either negative or positive. It doesn't really matter. Same thing with the range.